Welcome to this lecture. Today, inshallah, we're going to have an example for climbing lane design, the starting and end of the climbing lane. So we have this example. It shows two cases where we have a 3% upgrade and 6% upgrade, and both grades are for 500 meters, 500 meters. And case 2, case B, the same elevation difference, but we have the 6% preceding the 3% upgrade. And now we want to identify the starting and ending of the climbing lane. Please notice that here we have the same grade difference. In both, delta is the same. The only difference is the sequence. We have a sharp grade in the beginning, then a softer grade at the end. In case 1, in case A, we have a softer grade in the beginning, then a harder grade follows that. So we are going to solve these and see how much difference does this affect the exiting speed from these two grades. So in order to do that, we are going to use the exhibit A23-2 in Highway Capacity Manual 2000, which is similar to, it has a similar one in Highway Capacity Manual 2010. So this is our example, and this is our case A. So in case A, the entry speed here, it's 90 kilometers per hour. Okay, so the first distance is going to drive for 500. So here we have this, the horizontal axis are the distance in hundreds of meters. So basically we are going to keep driving on until we reach that point. When we reach that point, that's the 3% grade. So this is going to be the exit speed from here. Let's look closely. I'm sorry. Let's just draw, use the ruler to draw a line. So that's almost the 75 kilometers per hour.
Victor?
Yes?
The distance should be 250 and 500.
No, it's 500 in the example here. We are not solving the case that we discussed yesterday. We have 500, 500. Okay? This is Talal or who?
Talal, Victor.
Yes, you sent me a message saying that you have a lab or something.
Okay.
Anyway, so that's basically 75. So what does this mean? This means the exiting speed here from that segment is going to be 75 kilo per hour. Okay? Okay, so that means the entry speed for the second segment, the 6%, is going to be 75. So now we are going to drop. I'm going to just change the color, and we are going to enter on the 6%. The 6% is here. So that's the entry. Okay, let me just change the font. That's the entry speed at this point. Okay, it's going to drive for 500 meters. 500 meters, it's almost the same like this distance. So let's just draw here a distance like this. I'm going to show you how we are going to use this later now. So basically, that's the distance Okay, we are gonna drive, the truck, or the truck will drive on that segment. So that means the exit speed will be that's the line for the 6%. So this is going to be the exit speed. So the distance from here is going to slide this way, and that's going to be the exit speed right here. So in order to get the exit speed, let's go and draw this line. So the exit speed will be something around 42 kilometers per hour. Okay, so that's basically the second segment, and that was on the first segment. Okay, so that means the exit speed here, I'm sorry, the exit speed here will be 42 kilo per hour. Okay, so now let's go to the climbing lanes. Where do we need the climbing lane? The climbing lane, we need it right from here, because after this point the speed starts dropping below the 75 kilometers per hour. Okay, shall we stop it here? No, we will keep it here until the truck accelerates and reach the 75 kilometers per hour. So how long we are going to keep it? Let's go back to the chart. So now the following grade right after the 6% is the 0%. So here it is going to start accelerating. So this is our target here. So it will hit that horizontal grade here, okay, and it will keep going until we reach the 75. Okay, now we need to determine this distance. How long is this distance? We need to determine the distance between here, that's the end, and that's the beginning of the acceleration segment. So that's the distance. We can just make an expert judgment and say, oops, based on the scale that we have, approximately we can say it's perhaps around 1200, almost. I'm sorry, 700. Or almost 650 meters. If we say this is 100 meter, so this is almost in the middle, something around that figure. Or you can just, measure it with the scale and scale it. So basically, the length of the climbing lane, or the is going to be an acceleration here for 650 meters. So the station start climbing lane start, it's going to be at station 0 plus 554.0 plus 500. That's this point. Uh, 0 4 5 0 plus 1 0 ends at after this point and after 650. So basically it ends after the start with 500 plus, it ends after 1,150 meters. So here plus 1,000 plus 150. So here 0 5 0, I'm sorry, 0.402 plus 2. That's the end of the climbing lane. Clear? Now let's go to case 2. The case of starting with the sharp grade, the steep grade, 6%, then the 3%. So we are going to start to begin with here we're going to start here with the 90 kilometers per hour, and we will follow this chart. So it's going to keep going until it hits here. So here it's going to hit here. That means the truck will drive on this. Then it's going to exit that segment at that speed. So when it exits that segment, it's going to almost be here 50, I think 50, perhaps 56 or 57 kilometers per hour. So let's mark this down here. So it's going to exit here at 57 kilometers per hour. Okay, let's now go to the 3%. That's the 3%. Okay, what does this mean? If we want to enter, we're not going to hit the solid line for the 3%. So what shall we do in this case? We are going to go, that means the vehicle will start accelerating. Okay? That means that's the 3%, that's here the 0%, that's the 1%, 2%, that's the 3%. Okay? So that means we are going to enter at this point, and the truck will drive for 500 meters, That's the distance. That is because from the dotted line to the dotted line, that's 500. So I think this is almost similar to the 500. So it will exit at that speed. What is that speed? That means it's going to just accelerate slightly, not that significant acceleration. So the exit of the second segment is going to be, I think, 59 kilometers per hour. So here we will have exit 59 kilo per hour. Okay, now we want to identify where we will need the climbing lane to start. Okay, we need first to draw a line here at the 75 kilometers per hour. Okay, that means after driving on the grade for this distance, let me just change the color. After driving on the grade for this distance, the speed will drop right here to 75 kilometers per hour. So we will need to have our climbing lane starting from here. Okay, so this distance is almost 200 meters. Almost. Okay, so that's the start of the climbing lane. Now, when we exit from these grades, we will have 59 kilometers. We want this to reach to be 75 kilometers per hour. So again, we will go and see it's gonna hit here on the 0%, okay, right here. That's the 0%, and we will keep going for 500 meters. Let me just draw a 500 meters. So I think we need to go up a little bit more. But here, no, not for 500 meters until we reach the 75 kilometers per hour. So we are going to stop right here. So this is going to be a little bit shorter than 500 meters. So if we are starting here, I think this is almost 400 meters. So this is almost 400 meters. The distance from here until we reach to this point. Okay, this is almost 400 meters. Okay, so this means that the climbing lane will start somewhere here and will keep going and continue for 400 meters, and is going to start here after 200 meters. So the climbing lane start equal 0 plus 554.0 plus 200 So this is going to be 0 plus 754.0 ends after this station by 1000 meter plus 400. So it's going to end at 0 plus 540. I'm sorry. Plus 1000 plus 400. So this is 0 dot, I'm sorry, 4, 5, and 9. 9 plus 1, 0. That's the end of the climbing lane. Clear? Any questions so far? As we can see, despite the fact that both cases, they look similar, but they are totally different. As you can see, the first case was severe, was harsh and severe on the trucks, because the exit speed here was 42 kilometers per hour, because it started with deceleration followed by deceleration. Here it started with deceleration, then followed by acceleration, and then acceleration. Any questions? Okay. Hold a second.